Hello everyone, welcome to day 4 of credit 6. We have a new definition here for square roots and radicals. B to the 1/2 power is equivalent to the square root of b. Or if I want to go more general, I can even say a to a fractional power, b over c, is equivalent to the c root of a to the b. So this b is the power on a, and c is the divisor of that fraction, or it's what's underneath the fraction bar. Okay, goes into the radical. So the square root is actually, you can put the index of 2 there. Nobody does. They just leave it blank because it's so common, right? So that's what the square root is this is a 2, and if it were the cube root, so I'd b to the 1/3 would be the cube root of b to the first. Okay, so that's what that definition is all about. So we have a few investigations here. So if we use our rules from before, right, we multiplied, when it was a power to a power, we multiplied the exponents together. So 2 to the 1/2, and then 1/2 times 2 would be 1. So this should be equivalent to 2. And that kind of confirms this definition, right? That 2 to the 1/2 is the same as the square root of 2. If I took the square root of 2 and I squared it, I go back to 2, right? So this is 2 to the first power. And multiplying those exponents, you see 1/2 times 2 is also 1. So this kind of confirms that result. And then you can explain that there. Okay, so then we do a couple of square roots, or using radicals. So go ahead and give us equivalents to these in numbers. So it's basically, what is the square root of 25? You could do that. And then we come to this one, which is going to use the Pythagorean theorem. So you may have forgot the Pythagorean theorem. Let me just remind you of that. So if you have a right triangle, you have a little leg and a big leg. Actually, in this case, they're the same length. So if you have any two legs, if you take the square of the first leg plus the square of the second leg, it's equal to the square of what we call the hypotenuse, the long side of the triangle, which is opposite the right angle. Okay, so a squared plus b squared equals c squared. So hopefully that refreshes your memory a little bit. So what is the length of the diagonal for these different squares? So we'd say 1 squared plus, right, this is also 1 squared equals the hypotenuse squared. So 1 plus 1 is 2. So 2 squared, or 2 is equal to c squared. So c would be equal to 2 to the 1/2 power, or the square root of 2. Okay, so that's the first one for you. But you can do those other ones and see what you come up with for the diagonal of each square. Okay, and then we're going to go through the same kind of ideas that we were using in the previous day, and we're going to do some justifications for each of these different types of rules and see if, as long as those rules for the integers worked, now we're going to see, like, do the rules work for these rational numbers, okay? These rational numbers that are fractions. Okay. So go back to that definition. Remember that this is 9 times 5 to the 1/2 power. And I think you remember that from the previous day, that you can distribute this basically and say it's 9 to the 1/2 power times 5 to the 1/2 power. And then 9 to the 1/2 power is actually this square root of 9, which is 3, right? So this could be 3 times the square root of 5 would be another way that we could write this, right? So that's the idea, is seeing how we can simplify these different radicals using the rules that we've come up with. Okay, and then this is an interesting investigation. So is this equivalent? They're saying it's not. So come up with a reason why, right? All you need is a counterexample to show that this is not always equal to that. So go ahead and simplify these expressions. Go back to that definition that 4, the top part is the power, and then the bottom part is the index on the square root, or on the radical. So this is just the square root. So you could do 4 to the 5th power, right? So this is same as 4 times 4 times 4, 5 times, right? And then in the previous example, you could show that it could be the square root of each one, right? So it could be 2 times 2 times 2. Well, you could break the square roots out. And then it's 2 to the 5th, right? 2 to the 5th is a way that you can simplify that. Okay? So go ahead and use those definitions. See if you can simplify this into a simpler form.